I guess yeah, when we look back over this presentation, and I guess when you see the end of Craig's there, you'll probably see this part where there's all of these samples and what have you. But yeah, and what do you do with all of this stuff? And I guess this is what the crux of the common reporting guidelines. This is where it sort of comes in as the challenge with trying to report, trying to communicate this information that's generated through the testing process. And so, this guideline, it's all about standardizing how geomet test data is structured, reported, and exchanged. The goals around that is to enable better integration and better analysis and value extraction of that data for the mining industry. So if we look around, at some of our peers, some of the other communities that are around us, they have good guidelines or some accepted guidelines and standards on how data is transferred between systems and between different groups. And so I guess what that helps is just the ability to integrate this data through through the industry and through the value chain. So as we know with geomet programs, it's a big part of it is generating large and complex data sets. But as we look at the spectrum of everything that's there, there's all of these different formats and all of these different ways of talking about the data and different terminology that's used. There seems to be so many idiosyncrasies, and that just creates difficulty around integration. And so that limits the interoperability, slows down analysis, and makes it hard to reuse this data across the system. So the core objective of what we're looking at here is to develop a set of reporting guidelines for geomet data, having some standard templates that vendors, organizations, users can refer to, that leverage common terminology, common data structures and formats to ultimately enable efficient data consumption and reuse. A particular aspect of this project is understanding we can't boil the ocean, so we've got to do this in steps. So we can't address every single geometallurgical test that's out there at the moment and in the future. So a key aspect of this project is to have a set of design principles and guidelines that allow us to extend this in the future to create additional templates or additional formats or code for different tests in the future, which just the next slide, Heather. It sort of leads us to this question of can you describe a flotation leaching experiment using the same terminology? The leverage is being able to use common terminology and common structures and I guess common philosophies to be able to represent the data so that you can extend that in the future and use it, which ultimately is why it took us a long time to come to this point where we're at, because we have had a lot of valuable input already shared by the community, which we're going to talk about today. And we've got to a point where we think we've got a good structure to move forward. Let's just next slide, please. Okay, so what's been the process? I guess you could liken this to a process of some divergent thinking and then convergent thinking. So initially, in a divergence area, getting an idea of the entire scope of what's in front of us is having the community help with defining all of the geomet test data schemas, all of the different types of data, different types of tests that are out there. So getting a better idea on the full scope of what's out there, and then moving into this consolidation or a convergent thinking. So moving everything that we've learnt from the community into a more consistent terminology. So through that divergent or that defining stage of this process, understanding what's common terminology that's used across the different tests, and then looking at specific categories of tests like comminution, leaching, flotation, mineralogy, and understanding what are the common tests, what's the data transferred, what are the rules and relationships and what have you in amongst the data. So as you can imagine, there's quite a breadth of data that's being collected there, or learnings from that. Now we're in this stage of consolidation, which is this convergence thinking of generating a common structure that's able to describe everything that we've learned. So next slide, please. Okay, so this template generation phase that we've gone through, we're very challenging at the start because of the scope of everything that we had learnt. So ultimately is to try and simplify this process is focus on particular use cases, and in particular one use case which was the most common, which is around the laboratory results being reported by a laboratory to a mining company, rather than trying to do everything. So it's just trying to start off with something, and a key reason for that is to keep it close to the business problem, rather than making it a technical or academic endeavor, keeping it close to what the industry needs. So the process through generating this common template was to assess all the findings of each of the groups that brought together the data in that defined stage, and to form this generalized story which describes the results. And so this story is a way of just describing a geometallurgical test, or the results that come back from a test, in common language, and just be able to talk about it as we would from human to human, and then let the structure flow out of it, let the technology or the solution flow out of that. Find if we can talk about these things in natural language, then the next stages can be easier to deal with. And so that helps identify the common terms, data relationships, and allows us to get into this definition. So next slide, please. So we're not going to go over all of the words in this, because we're going to pull it apart in the coming slides. But this here is the generalized story of a test. So as you can see here, just trying to bring out natural language, talk about what is it that's been reported, what are the particular aspects or parameters or the attributes of the data that's been returned, what are the idiosyncrasies, etc., that are able to capture the variability across with comminution, flotation, leaching, mineralogy, and all of the different variants within that. So it's just creating this common story. So let's go through that. Hopefully this is making sense to people, but hopefully it'll make even more sense as we go through it in these next slides. So ultimately, what we're trying to do here is just create this hierarchy. Ultimately, that's something that'll flow out of this. And just saying, well, what are we doing? Because the data being reported are the results of a test on a sample. So a test is a particular type, and so and you're doing it on a sample, and so a sample will have descriptive attributes as well. So whether they're measured or observed, they might have preparation steps. So it's just allowing that information to be recorded. Next slide. For a test, it'll have parameters that are recorded when it's run. And so these are controlled input variables. They might be observed or measured, and it might be targets. And these are descriptive type parameters for a test. Using flotation as an example, a parameter for a flotation test might be the cell type. That might be one of those parameters that you're looking at. So it's defining this overall input variable for the entire test. But then if we go to the next step, is when we run the test, it'll be run through one or many stages. And I'm sure that those that have been through geomet test results understand what these stages might be, but it go through stages, and each one of those stages may have parameters. So for example, in a flotation test, it might be the amount of reagent that's added into the cell throughout the in that particular stage. And from that, at the end of that stage, there'll be outputs. And so those outputs might be things like, the dry weight of products, for example, or masses, that type of thing. So it's what's the outcome of that stage. So again, just trying to break it down. So these, that might also be samples that are taken, which go off for further analysis. So it's defining what those outputs are. So a test may have multiple stages, one to multiple stages. Then the test itself will have outputs. So in a similar way that we're talking about, the masses, for example, or samples that are taken at the various stages, there may be an overall output for the test. But then also these key results, that it report, and these are ultimately the findings for the overall test. So these are things that need to be reported. This is the reason for doing the test. So it might be in the flotation example, it might be the metal recovery or the mass yield, for example, or particular grade. So these are things that are reporting. So hopefully you can see through these different sections is that it's categorizing the results into more simplified areas or components, make it easier to be reported and to be identified. And hopefully also you can see that with any of the information that's recorded in any one of those areas is that it can have type information. So was it observed, or was it a measured result, or what were the units, those types of things. So we can extend it further there. So when we look at this overall, again, I'm not going to go through each of these in detail, but come up with definitions of what are each of these areas of a test or the test results, allowing us to start to have a common understanding of what are these things that we're reporting, and then being able to apply that to different sorts of tests, whether it's comminution, flotation, leaching, or any of the variants that are within that. Now, I'll just share my screen. So just as to, how does this look in practice? So what we've got here is an example of how we're looking to represent these guidelines to the public and to the industry. And so the method of publishing this is through a GitHub website. So GitHub is a cloud-hosted repository used commonly in the software industry. But the key aspect here is that it's open cloud-hosted, so they are very accessible and also able to be used as a collaboration environment for future derivations. So here, being able to represent the guidelines, being able to have a glossary so that we're able to get into common language. So here I could search for recovery. And here it's if you're having trouble, what's recovery, how's it used, what's its definition, being able to search through it, find out the definition and where it's used. So making it quite easy for users to and the industry to get into it. And then for each of the different types of tests, being able to find additional information on that and how this template is applied to that type of test. Okay, so that there's direct access to the guidelines as applied to flotation, leaching, or mineralogy. So hopefully that that communicates to you. You can see how we can engage the industry with the results of this quite easily. So it's easy to access, easy to search, easy to download and apply. So it reduces the friction in getting this accepted. Heather, if I can show that final slide, please.
Is it this one or the next one?
Just the next one, please. Okay, so yeah, the deliverable, what I mentioned there was the GitHub hosted website. Updated without the detailed programming knowledge, so it's this collaboration environment, so posting of all of the templates. Next part of that one, I think it was actually the following slide, which is helping with the contribute. So yeah, getting involvement. So really, we're in this point where we have template, starting to apply it to the different types of test. What we're looking for is populating that GitHub repository, getting feedback on the template and the structure of the template, making sense, iterating that to ensure that it is able to represent the different types of tests, so that it is valid and very well closely aligned with the industry needs. So use the QR code there to get involved. Be lovely to see more people.